The issue about this whole educational area with the logging contractors has been made more apparent by the efforts of certification. And so many of the contractors who are participating in the Sustainable Forestry Initiative or other kinds of certification schemes require that the operators have training and education as part of this certification. Sometimes it involves business management. And so within Oregon, for a lot of years, I did a program called Logger Education to Advance Professionalism. And that's what this course on understanding forest operations costs and bidding practices or pricing practices was about. One of the analogies I think that makes a lot of sense is to think like the fire triangle that's so familiar to everybody that they can see the logic of a three-cornered stool or three parts of the triangle necessary, fuel, oxygen, and ignition source to have a fire. We have the same thing when we talk about the what I call the logging business triangle. You have to have the resources to be able to do the job, and that's the equipment, labor, capital, the timber available to you. In addition, you have to have some productive capacity, and that's brought about by selecting and training your workers, the management that the owners typically bring to the job, the planning that's done, how you manage values and quality on the operation. That gives you a productive capacity. And then finally, you have to have a logging opportunity, in that particular case, by virtue of a successful bid, if you're in a bidding scenario, or some kind of successful negotiation. And that gives us the three parts of our logging business triangle. What is surprising, however, and why we have some disconnect between some managers, is that some of the managers in firms that hire or contract for services come from manufacturing processes, and they really are more familiar with serial production activities like you have in a sawmill or even a pulp mill. And they're different. In those serial production operations, you have the resources ready at hand. They're there ready for you to transform them. Or you assemble a product, like making an automobile. You have all the pieces there, you put it together. You have an assembly line oftentimes. It's linear production. One part follows the next. In these operations, you might have uniform products that you're producing at the end of it. A 2x4 is a 2x4. You know, a Ford Focus is a Ford Focus. The labor is oftentimes specialized in one particular task, and you have individuals highly trained to do that kind of work. You have many less uncontrolled factors when you have a roof over your head and everything is all under a controlled environment. Lots of improved safety and work environment under those circumstances compared to what we'll see as a project type operation. Most of those factories and serial production are year-long operations. When you go to a project-based situation like a harvesting operation, the resources are changing. Your starting conditions are always different. You end up with a business where you're transforming resources. You're not making things necessarily, you're transforming the resources in that particular operation. It's often nonlinear. You got things spread over the unit. You're doing one thing at one time, and you may have to jump over and do it in another place at another time. It's not direct. You're producing variable products, 26 sorts, things like that are part of it. You have to have both general and specialized labor. It's not just a matter of having a specialist who can only do one thing. You got to have both types of labor pools. Lots of uncontrolled factors. Lots of difficult safety and work environment conditions. As part of our synthetic rope research, I managed to do some heart rate measures of young workers aged 25 to 40 or so, and we found that in order to get a resting heart rate out in the forest, it was very difficult or nearly impossible, because just standing around in a woods environment raises a heart rate about 20 beats per minute, because you're not in a controlled situation. You have lots of things around you. You're not on a flat floor. You have all sorts of things taking place, and it's simply a different work environment. The production is project-based. It's not an annual operation. You finish one job, you move on to the next job. Well, that distinction is lost on a lot of people who are just looking at the types of production that they have in their factories. The other thing is that the cycles are significant for these operations. There's natural cycles, the kinds of things we have in terms of a climate cycle, summer, spring, fall, winter, rainy, wet season, and the like. There are economic cycles. We're coming out of a pretty tough time economically, at least from the operators that I've seen, and are beginning to get a little better, at least in terms for the logging contractors. Not in all places or in all conditions, but there was a time when we had way too many logging contractors chasing too few jobs. Now that's not the case. There are social or institutional cycles. We were in a pretty bad pendulum swing when Ted Turner was doing the cartoons Fern Gully, so that the kids were seeing a logger who was out to destroy all the trees in the world on the cartoon shows on Saturday morning. That's moved back away to the point where a number of people are recognizing that if we're going to keep our homes and cities safe from fire, we better do some management in the forest. And these social or institutional cycles come into play. Some of these cycles are short-term, some of them are pretty long-term. And you have to consider that as you look at these costing influences. Some of the cycles, you can figure them out. Others, you just don't know where you're at. I mean, if we look at the land ownership patterns of some of the major corporations in America today, I'm not sure what kind of a cycle we're in, because we've changed from a corporation perspective, which is an infinite lifespan, to a timber investment management organization that may have a 5-year investment cycle. Who knows where we're at? And we don't really know for some of these cycles. And then finally, some of these cycles we can change or alter them to our own benefit. Others we can't really tell. So all of these factors are influencing our decisions about costs. We started our discussion yesterday about the types of logging costs when we were talking about equipment, and the costs still fit. I won't go through these two. We talked about them a bit already, but when fixed costs are costs that accrue to your business no matter what you do. As soon as you open the door of your office on the first day of business, you had a set of fixed costs that you're going to have to cover by your activities. And it's the house or the home office that you were in, the shop out back, all of these things that were a part of it. The variable costs change with how much you produce. If you produce more, you often burn more fuel. If you have more work to do, you use more labor. If you hire subcontractors to do more work, those things come with production. Maintenance supplies are typically. What I'd like to talk about in greater detail now are these lumpy costs that we mentioned yesterday. And these are costs that are related to demands or requirements on the job, but they're not really fixed or variable. And a classic example is that you just took a job up here in the mountains and you just got started work, and all of a sudden you had this heavy rainstorm and snow come in. And what you find out, just to get to work or get the trucks into the log, you're going to have to hire 10 loads of rock to be brought in on the road surface. You didn't budget for that, you didn't plan for that, and you got a lump. Okay? And that's kind of a lumpy cost. And that lumpy cost then can happen sequentially. Let's say you do that, and that part of the road is okay, but you go along and you work for a little while longer, and pretty soon another part of it goes to pot. Then you may have to add some additional rock there. Another lump comes in. By the time you get done, you find out you put $15,000 into rock on that job in a series of lumps that you just are going to have to somehow try to find a way to cover. If you have some,
the mill's not going to pay for it.
Well, that's what I was just going to say. If you have a fixed cost contract, that's a lumpy cost that you're going to have to absorb. So we'll talk a little more about that. And then opportunity costs are this notion of carrying out the lost potential from doing one action when you could have done another. Now, this also occurs from taking two jobs. Let's say you have two jobs that are out in front of you. If you take this one that is going to end up with a $15,000 road job on it, and the other one would not have had it, you had an opportunity cost there as well. Because if you'd taken this other job, you might not have had that, or there might not have been any opportunity for it. You might have been on a rock road already. Those opportunity costs are seldom considered in thinking of operations, because you have to anticipate a future action and judge it against a present course. And those costs can be significant. We used the example of having a piece of equipment that you don't need. One of Al's decisions was to sell some of the equipment that he didn't use continuously. And he had an old front-end loader that had been used for 25 years. Cost him hardly anything to use, but he needed it at times. He kept that one and sold his crawler tractor that he didn't use as much. We have costs that are linear in form. And you have an example there with this skidding distance example. We have several types of vehicles here. This one on the bottom is a rubber-tired skidder, RTS. It turns out that it has the lowest cost related to average skidding distance. And if you look at this chart, you can think of the axis here as being the fixed cost component, and the line going up as a variable cost of the operation, because it changes with how far out you go with the operation, how far you skid. So that's another example of fixed and variable costs. We also have a D6 in this example, and it has higher fixed cost to begin with, but its variable cost rate is almost the same as the skidder. We have a smaller machine that costs somewhere between the two for fixed costs, but as you go further away from the landing, its costs go up faster. And then you have what was at the time an FMC vehicle. It's now called a KMC vehicle. It has higher fixed costs because it's a more expensive machine, but it operates at about the same rate as the D6 and the rubber-tired skidder in terms of variable costs. And then finally, you have a forwarder that has the highest fixed costs of all, but doesn't change much with distance away from the landing. And what is interesting about this is that we can look at things that are termed break-even analysis. Where these lines cross, we can say, well, if under all circumstances until we get clear out to maybe 1,300 feet of average skidding distance, and let's say we have a road here, the average skidding distance is for this area is what? It's a linear road, and we're going to just skid to the road. What's the average skidding distance? You got some from the front, you got some that's real close. Turns out it's right in the middle. Yeah, okay. So that average skidding distance that we're talking about here is the average skidding distance. So it's the external distance is 2,600 feet that we're talking about there, or almost half a mile or so.
On each side of the road.
Well, yeah, either way, but just whatever that distance is what we're talking about with this average skidding distance. And this says for our break-even analysis, the rubber-tired skidder is always cheaper. Now, we can't always use rubber-tired skidder. If we're going to use this little small crawler tractor, that's only good for about 300 feet of average skidding distance. Then we'd be better off using a D6, because the further out we go, we can take bigger loads and bring them back to the landing. Under these circumstances, with this equipment, when we got out to about 600 feet, we'd be better off going with the forwarder. And under no circumstances except for very short distances, does this KMC vehicle beat the others. So we can look at these break-even analysis when we have an understanding of the way these costs behave. And these are straight-line costs. Here's an example where we have a feller buncher, and this is the travel distance between where it has to stop and process. So if it has to go 20 feet between stopping points, it has a particular price. And we have 3 different machines here. They operate differently. But you see that as you go out at 20 feet, the cost per ton is different. And the analysis here says for every 10 feet of distance that you got to move that machine to begin processing wood, it's going to cost you about $1 a ton. So the implications are for widely scattered stands, you're going to end up paying more trying to use a feller buncher to process it, because it's really sensitive. It does its best work when it doesn't have to go far and can process everything around it. That's the kind of analysis that we use for, again, these straight line costs.
Is that from the landing?
This one is this one is the distance between points where the feller buncher has to stop and process.
Okay. In terms of you do this clump, or you do this clump?
Yeah, right.
Okay.
Or you move ahead. Now, at a minimum, you probably have about 10 feet or better, because you got to have room to stack things and so forth. So the reality of it is you don't ever have 0 as a distance. You can't reach everything. But the length of the boom and stuff is such that if you got very dense stands, you just move the machine ahead a little bit, and that's not too costly to do. But if you got to move out there 30 feet to the next operating point, the costs go up linearly in this example. This is another effect which we find quite frequently, is this downward sloping J-shaped curve, and this is the effect of the volume harvested on the operation. And so we have all of our fixed costs that we have to cover, and if we only have a little bit of volume to cover it, the costs are very high and the curve is very steep. It isn't until we get out, 400,000 board feet or so in this particular example. This is an example. Everything is relative. You can make one of these curves for your own business that you're in now and see what kind of minimum amount of timber you can afford to harvest. By and large, most people need to spend about a week, in an area to cover their moving costs and so forth. So this little 2-day, 3-day jobs are just killers because you're not harvesting much volume. But this curve shows that until you get out with a sufficient volume, your costs don't stabilize very much. They're really high. Log size is a classic one. The smaller the log, it's the pizza example again, the 12-inch log versus a 24-inch log. And as this board foot log size is in this high range, we're in the steep part of the curve. Now, this is a log size of 150 board feet. That's a pretty good sized log in this example. And when you see where we're operating now, a lot of our logs are in the 40, 50 board foot size. So you're in the steep part of the curve in most of your operations now when we're handling this real small wood. This is an example for a particular type of logging operation, but it shows the shape of the curve again. That's true up to a point. And if you look at this one in your page 6 of this first section, we hypothesized before we got ever into mechanized harvesting is that this downward sloping curve that we were talking about might eventually go back up because we'd be overreaching the capacity of the machine. Well, this happened to be a study that we did in Eastern Oregon that showed what we call the bathtub curve, is that, once you get up about 16 inches or so, the costs are starting to go up rather than as timber size increases, because you have to do something special. You may have to cut one side and then the other to get the tree down. And what we saw also is that machines kind of operated differently. This one wasn't as bad. I don't remember which machine it was. I think this is the larger cat machine, but it doesn't have a very sharp bathtub curve, whereas this one comes down and then reaches a maximum and goes up much faster. So it's the shape of these curves and the costs are critical. So when you're running your business, you got a little mechanized harvesting operation, you're going to try to keep that oversized material, out of the way.
One of those at Timco?
No, it was the ones that we saw, John Deere 650 cat and a Ponzi, I think it was, in that study. Here's the example of our lumpy costs again and how they might go up. This is an actual example relative for a job that incurred different levels of slash cleanup. If you had a slash cleanup that would be done just to meet the forest practices requirements in Oregon, that was identified as 100%. Okay, and that level is what we typically experience, so we're not seeing any increase in cost. If a landowner wants a little extra cleanup and you can do it with machinery, you might have an increase of about 10% or so in the slash treatment costs. It's not that bad, people can do it. This came to my attention when the landowner and the logger were at really sharp odds. The landowner expected a part when the logging was done. The logger did not expect to produce a part, and there was clear collision points. And the reality of it was, in order to get payment for his job, the logger had to hire a hand crew to go in and pile stuff by hand. And for the site preparation costs, added about 60% more than what the codes would have required. And he very grudgingly paid that, but as a response to being able to get his final payment for the whole job. And so that was a miscommunication and a lumpy cost that he experienced. What people who are not familiar with your business, now that you're in it, was that you're going to have to somehow account for these lumpy costs, or to some extent anticipate them in the course of your business. It's pretty easy to see the cost that buys something. You know what the fuel bill is. You know what the price of a new machine is and the equipment that you've got. If you have to pay the landowner for timber, you can see that price directly. If you hire somebody to do maintenance on your operation, you get a bill from them. You can see those costs directly, so they are really out in front of you, and you see them, and they buy something. There are a lot of things for which we end up putting money forward that we can't see the result of, and these are such things as safety. I can't tell you how much to spend on safety, but I can tell you what it'll cost you if you have a severe accident to a key operator, and it will be excruciating. I can't tell you how much to spend on training, but I can tell you the cost of ignorance if you roll a machine over. I can't tell you how much to spend motivating your people, but I realize that when we have highly motivated individuals, the production differences can be at least 30-35% different between the same individuals who are motivated or not. So that is something to consider. I can't really tell you how much to spend on the management of your firm, but I submit to you that most of the people in providing logging services or forestry services are underspending on their own management time. They're driving back and forth to work thinking about the jobs and their business, but they're not writing it down. They're not doing specific management planning activities that would change the way they're doing business. So we're underinvesting because we don't see what it takes to put that money into some kind of a cost result. We don't know what to spend on quality. But if you get the logs rejected and you got to go send a truck to a mill and pick up a load of logs on the ground and haul them somewhere else, there's a cost to doing that. Public relations, advertising, who knows, You can't really see what you're getting for the cost. Some things money can't buy you respect. You don't see that anywhere. Or loyalty from your employees. You can't buy that from the crew. You're not going to buy your way with customer relations. You're not going to get the right attitude by spending on it. You have to do some things that are different than that. And like the saying goes, money won't buy you love. So lots of things you can't really see what's happening. It may even be amazing that we make the progress that we do, under these circumstances. I looking over the course of my career and see the things that have changed, I'm surprised that we make any progress at all, because it's not happening smoothly. What I found was that underneath everything we do, there is this learning curve concept at work. And there's the way we're doing it, the old way that we're doing things, and then there's a new way that's improving in some fashion. Our time per task in this particular example, it might be from a training program, it might be our learning on the way we're using our new machine or whatever. It might be our selection of the applications for the equipment. But we do make this improvement, and there's a difference. The difference between these two, the old way and the new way, ends up being this cumulative difference. And it has a characteristic S shape, because you start out with a little gains at the beginning, and then they begin to accumulate, and pretty soon they level out or just increase at a steady rate. That's kind of behind all of the stuff that we're doing. And that shape of that curve was intriguing because several years before, in the early 60s, a Norwegian scientist that I worked with, Ivar Samset, said, "I'm having trouble explaining what's going on for the evolution in forestry equipment." You remember that Nordic trajectory that we're on? And he came up with this law of discontinuous evolution. Now, evolution is sort of being continuous, but for his perspective, it was discontinuous. And here's what he said was happening. That during stage one, there was a pressure building where the costs or some other pressure was building such that we had to do something. And if we decide to do something, when we start out doing it, we don't gain much to begin with. We try a bunch of things. Some of them don't work, but eventually we kind of hit on something. And then a development stage takes place. And so during that development stage, we finally get to the point where we can see the light, and we got gains and you know, that are ahead of the pressures that are building. And so when that happens, we begin to introduce the new technology, whatever it is, and we get this third stage where we get the most of the gains from the new development. And that gains continue, and eventually we get back out to this point again, and we're back at stage one. And what he was saying, and which I found extremely enlightening, is that this is happening all the time. We're on a bumpy road. You know who's got the smooth trajectory with this old way and the new way? Electronics industry. I mean, every 3 years the prices are being cut in half for things like memory or capacity or whatever it is. The space race had that trajectory, or just a smooth trajectory, because they were putting huge investments in research and development. You know how much money in the forestry sector is put into research and development? Way less than agriculture. It's hardly anything at all. The forestry sector is completely, particularly for forest operations, underinvested. We have a lot of investment in research on basic forestry, but hardly anything in the operational aspect of forestry. So that was what Samset was saying, and it realized that this is happening all the time, and we just can't see it. And this kind of advancement is taking place.
What would you say the next innovators will come from? The Scandinavian countries have done it now for 30 years.
Well,
they
have and they haven't. For one thing, the Scandinavians were really involved in technical developments through the early 1990s. During that time period, most of the Scandinavian firms were bought out. John Deere owns Timberjack, Komatsu owns Valmet, and Caterpillar owns bought out several other firms in Scandinavia. So we're dependent upon those firms to some extent for developments. The reality of it is that once the concepts are identified, these larger firms can put them into play by new machinery and development. But where do the concepts come from? Most often they come from contract loggers and people in the business themselves. There's a concept that's on many machines now. It's called a squirt boom. And it allows the boom to extend a particular distance, and there are two box beams put together, and then using a hydraulic cylinder you can extend the internal box beam out another 8 feet or so. The squirt boom then extends the reach of a small machine from maybe 20 feet out to about 28 or maybe 30 feet. That concept was developed by a logger in Sweet Home, Oregon, who wasn't satisfied with the reach of his timberjack harvester machine. The squirt boom concept had been around for a long time because we used to use it on grapple cats when I worked for Weyerhaeuser, where we had a boom on the back of the cat, on the top of the cat, that would push the grapple out about 10 feet so that it would drop on a log that wasn't sitting right next to the crawler tractor. That squirt boom concept was technical developments by individuals. What we're missing, though, is the intermediate assessment stage and the stage to take from a logger's idea, who's working with it directly, into something that validates it, where manufacturers will want to take it on as a project. And that's has been university research and development has done some of that. The companies used to do a lot of that themselves. Weyerhaeuser used to have a large research group that would do that. They don't have anything anymore. The TIMOs, the REITs, none of those people have research and development. So it's going to have to come from the individual logging contractors, the people like you who own those businesses.